9.4 volume of a prism. We've been working with surface area, which is basically how much wrapping paper would it need to take to wrap around the outside. We're going to now be talking about volume. And volume is basically how much space does the whole object take up. If this is an empty shell, container, how much could fit in it? So finding the volume of a prism, there are some similarities and some differences. One of the similarities here is that you're still going to need to be able to find the area of the base. Okay, now in a rectangular prism, that's just basically taking one of either the bottom or the top or the left or the right or the front or the back. Take one, find the area of it, and then that's going to be the bottom layer. But then to figure out what the whole volume is, we'll multiply that by how many layers there is. So basically the height. On a triangular prism or otherwise, any non-rectangular shape is going to be the base. So this is the base. So you're going to find the area of this here. And then, again, multiplying it. That would be your bottom layer, your first layer, and then multiplying it by the height, which would then tell you the volume of all of the layers. Okay. So that being said, the surface area, the volume formula is much easier to figure out. Basically, it's the area of the base times the height. And that height is the distance or that connection between the bases. Front and back here are triangles. What is the distance between those? 5. That's your height. All right. So volume is a lot less technical as far as I go. Well, let's take a look up here, and let's just say that we had some dimensions here. So let's say we had 4, 6, and 10 here. So the volume would take the area of that base. Well, the area of this base would take 4 times 6. So that's 24. Okay, so in this scenario, I'm going to just bump this down here. Our base is 24 times the height, 10. So the volume would be 240. And so that's that first one, and then whatever units cubed, and that's the difference. So let's say that these are all centimeters. This would be centimeters cubed. So our units are cubed. And that is one of the questions in the Big Ideas math. So units are cubed because it's 3 dimensions, right? Area is 2 dimensions, length and width. And so it's squared. Volume is 3 dimension, so it's cubed. You can kind of see then when we're looking at these rectangular prisms, it really ends up just taking the 2 numbers on the bottom and the number on the side and multiplying them. But just thought I'd point that out. All right, so this one down here, so I'm going to go ahead and move this down here. So the volume is the area of the base times the height. Well, the height is I've made it kind of clear, it's 5. So the area of the base, we just have to be careful because it is a triangle. Okay, and a triangle is half a rectangle, so it's 1/2 times base times height. So 9 times 8. So so this triangle, 9 and 8, is going to be 1/2 times 9 times 8. And I don't know, I like to half something before. So I'm going to go ahead and do that. Any of these dimensions, because it's all multiply, put a little times there, make that 4. So that makes it easier for me because I can do some mental math. I do a little regrouping. 4 times 5 is 20 times 9. And then 9 times 2 is 18, add that 0. And so for me, I could do all that mental math and it makes it a little bit easier, but you could just make it 0.5 and plug it into the calculator as well. Okay, and so that is how to find the volume of a prism. So I want to just take some examples down here, and I want to show you a couple of different things that you could see on Big Ideas Math. So on this one, like I said, when it's a rectangular prism, it really doesn't matter which one is the base and which one is the height. You end up, let's call that right side, that base. So you end up with 10 times 20. But then that third number is going to end up being the height. So 10 times 20, well, I've got 3 zeros. 6 times 2 is 12, times 1 is 12. So it's going to be 12,000. And you could use the Desmos calculator to confirm that, but it's just basically multiplying all three of those numbers. All right, so number 2, volume equals area of the base times the height. Well, that base, it does have a non-rectangular base, so that base is going to be the triangle. So 1/2 times 10 times 15, and then times the height, times 25. And so this is going to half, so that's 5. And at this point, it's really going to probably be a calculator. 5 times 15 is 75 times 25. But like I said, 75 times 25. I don't have a calculator on me. So that is going to be 75 times 25, 1875. So just double checking my work. Okay, so it's going to be 1875. So volume equals 1875 meters cubed. And then we get some like number 3 where we have some decimals, and we're definitely going to want to probably use the Desmos calculator. Volume equals area of the base times the height. Volume equals 1/2 times 5.2 times 3.5, and then times the height, which is 7. Okay, so 0.5 times 5.2 times 3.5 times 7 equals 63.7. And so I just, you just plug that into the Desmos calculator. And for some of these with more complicated numbers, pretty easy to do when you have that. Area of the base times the height. Well, doesn't matter, I guess, which one we consider the area of the base. So I've got 1 times 2.5 times 9. So it's basically 2.5 times 9, 22.5. So equals 22.5. And so you just get that idea that that's the direction we're going. So we've got volume equals, and the triangle's this front one here. So 1/2 times 6 times 1.2 times 3. And so I'm just going to half that. So we end up with volume equals 1.2 times 9. So see my regrouping. So 3 times 3 is 9 times 1.2. I like that because 9 times 12 is 108. So 1.2 times 9 is going to be 10.8 yards cubed. Now this one is interesting because they just give you what the area of the base is. So there's a few of them here where you're going to be given B. What that means is there's the formula for finding that's a little bit more complicated. So they're just going to give that to you. And so when you talk about the area of the base times the height, this 86 is going to be that area of the base, and then times the height, which is 15. So that's all you end up doing is 86 times 15, which is 1290. And so in a way, even though it's kind of weird and you're not sure what to do with that, once you know what to do with that, it's really easier almost. How do you know that that is the area? Well, another clue besides this letter, but that's B, so you're not quite sure. The meters squared, m squared. Okay, and so that m squared tells you that that's the area. All right. All right, let's look at this one here. The mailbox is in the shape of a prism. The area of the base is 52. So again, they tell you what B is, and the height is 18. What is the volume? So if you end up with one like this, the area of the base times the height, oh, that's just going to be 52 times 18. And so it's a word problem, so you think it's harder, but it's not. And you'll see some different variations of that. But if you multiply that out, it's 936 inches cubed. Okay, I'm not going to go any further than that. So that is how you do 9.4. Let me know if you have any questions, and hopefully that will help you. Thanks.